all the dear students. This is chapter number 11, Coordinate Geometry, part 1. This is very interesting chapter in which we are going to learn some different formulas. So in this part, I have explained you distance formula, section formula and midpoint formula, and also students one centroid of the triangle formula. Chapter 11, Coordinate Geometry. Students, today I will explain you about the whatever the concepts we have already studied in standard 9th. So today we are going to study about Cartesian coordinate system. There are two types of coordinate system. One is Cartesian coordinate system and the other is polar coordinate system. But today I am going to explain you about Cartesian coordinate system. Now this name Cartesian is from the big mathematician Rene Descartes. From his name only this Cartesian coordinate system is named. Now in our Cartesian system we all know that there is a 4 quadrants, or you can see on the graphical representation you can be given like this: x-axis, this is kind of x-axis, and this is y-axis here, and this is the origin. So on the right side of the origin on x-axis there are positive numbers, and on the left side of the origin there are negative numbers. Similarly, on the upper side of the origin there are positive, and on the lower side of it negative numbers. So similarly, now x-axis, y-axis, and this is origin. Similarly, this is x dash and y dash. Why? Because the left side from x we write as x dash. Now students, if we want to know some perfect position, so if suppose I give a point here, suppose this is the point here I am taking, so I want to know where this location is lying. So for that this Cartesian system is very useful. So here if the point is drawn, so what is the x coordinate of it? This is 3, and the point is lying to the straight off on the y-axis, so the y coordinate is 4. So the point lies, the coordinates of it is 3, 4, which we have already studied in standard 8 also and 9 also. You know, plotting of points we have studied. So likewise this is our x coordinate and this is our y coordinate. So using these coordinates we can plot the point in our graphs. Also the negative side if you want, so this is x coordinate negative. So how do we write? This point is -2 on the x and 1 on the y. So likewise you can write -2, 1 on any same point. This same point will not lie anywhere. You can see this same point's coordinates are 3 and 4. So if it lies here, the coordinates will change. How? It will come -3, 4, not 3, 4 the same. So from that you can see that here both the coordinates are positive always, and here x coordinate negative and y coordinate positive. Then next, here in the third quadrant the x coordinate negative and the y also negative. In the fourth quadrant it will be positive negative, x positive and y negative. So these are the coordinates. We call it x coordinate and y coordinate and their signs. So this is the first quadrant, this is the second quadrant, the third quadrant and the fourth quadrant, which we have already studied in standard 9th according to our Cartesian chapter for coordinate geometry. Now one more thing, that what this 3, 4 are called in another way. First I said that they are coordinates, but that x coordinate is also known as abscissa and y coordinate is also known as ordinate. So these are the names I am writing here: abscissa for x coordinate and for y it is ordinate. So for y ordinate, these are the other names you can see: abscissa and ordinate. Also one more thing I want to tell you students, that this 3, 4 or any point you take, the coordinates are showing us the distance here. So students, in 9th standard you have already studied about distance formula. So here I tell you that how this distance we have to explain. You see, on the x-axis, this from 0 or this coordinates of origin, we all know it is 0, 0. So from that it takes 3 centimeter distance. So we write here x coordinate 3, and from y here, if I draw this way a rectangular, so you can see this Cartesian coordinate system is rectangular. Why? Because it makes rectangle here. Now you see that the 3 centimeter distance is covered on x-axis, and on y-axis 4 centimeter distance is covered. So accordingly the points are 3 and 4. But what this x coordinate is showing, it shows the distance on x-axis, and what this y coordinate is showing, it shows the distance from the y-axis. Distance on the y-axis, you can see 0 to 4. It is the distance on the y-axis, and this is the distance on x-axis. Now students, you may have the question in your mind that suppose the point is lying here. I am taking the point in third quadrant. So this is the point, suppose -3, -2, right? -3, -2. So this point, what is the distance it shows here? So for that, if I draw a rectangle again here, so you will say it will cover -3 distance on the negative side, means on the x-axis, but it is not like that. It covers 3 centimeter distance only, but it is on the negative side. Okay, so -3 is just the point, but distance on the x-axis is always positive. Distance we do not write on a negative anyway, but it is always showing a positive. And on the y-axis also it shows 2 centimeter distance. So this way you can understand any point of their x and y coordinates are showing you the distance only, but in positive, because distance is the never be negative. We do not write distance quantity in negative. If it is negative, then it may be on the left hand side, or it may be on the downside, or you can say the origins downside, it can be. Now suppose you are told that your father's office is here and your school is here, and what is the distance between the distance between the school and the office? So you want to find here distance. So for that you are given some coordinates. Here suppose 4, 2, and here suppose 1, 3. So using this you can find any distance that you are already explained how. So the formula for distance I am writing here now. So here I have written distance formula. D is equal to square root x2 minus x1 whole square minus y2 minus y1 whole square. Okay, so I was explaining you the example of the distance between office and school. So here we are given 2 coordinates. So let one coordinate be x1 y1 and the other be x2 y2. And now if you want to find the distance between them, you can place them here. Suppose here x2 is 1 and x1 is 4. So whole square minus y2 is 3 and y1 is 2. So now placing them in the formula, what I get, 1 minus 4 is minus 3 square, and minus 3 minus 2 is 1 square whole square root, and minus 3 square is 9 minus 1. So that is square root 8. So you can write 2 root 2. The square root of 8 is 2 root 2. So this way students, you can find any distance in any way. It can be anywhere of some distance if you want to find using this formula as I place the values. Now somewhere it is written x1 minus x2 whole square minus y1 minus y2 whole square. In some textbooks or some publications they give formula like this. So first x1 and then x2. So no problem, because when you make a square of any number, suppose here -3 and there is square on it, so square will be always positive number. So doesn't matter what it is, x1 minus x2 or x2 minus x1. By making the square on it, it will become positive value only, and then you take the square root, you get the same answer. So don't worry students, somewhere in x1 minus x2 or x2 minus x1 doesn't matter. Now let us study about our internally division in some ratio. So here is a line segment AB I have drawn it on the x-axis, you can see. So no problem, I am writing here x, this is origin and this is y. So in Cartesian geometry I am explaining you this way, that suppose this is a line segment whose points are A and B and it lies on x-axis. Okay, and some point P is there which is dividing a line segment AB in some ratio. Now we don't know the ratio here, so let it be m ratio n, suppose. Okay, means AP ratio PB is equal to m ratio n. We are taking m and n, suppose some numbers. So this is the section, or you can say the division of this line segment AB in some specific ratio. Now let A be x1, y1 and B x2, y2 and P be let some xy point. So that I am writing xy point. Now P is the division point of this line segment AB. Okay, so what I explained you prior, that any point on the x-axis or in any quadrant or on the y-axis will show us the distance from the origin. So here also point A will shows us distance x1. What is the distance from origin? x1. Similarly here point P has distance x and point B has distance x2. So see students, how we can explain you that how x1 distance from origin, this is x distance and this is x2 distance. Okay, now we want to find the distance from this much, AP distance. So AP distance will be here, you can see this is whole x minus x1, that will be AP. So x minus x1, and how much is PB? PB is this much only, so that is whole x2 minus x. So here I write PB is equal to x2 minus x. So this way I get two distances AP and PB, and also we have taken the ratio AP PB m ratio n. So we can write now AP upon PB is equal to. So now I can show you how we get a formula here. This ratio is m ratio n, and also the value of according to distance is x minus x1 upon x2 minus x. Now what we want? We want actually x value here, x coordinate. So for that I take all of them on one side by cross multiplication like this. So I am writing here mx2 minus mx is equal to nx minus nx1, this way. Now I take all the x term together, so I get here minus nx minus mx is equal to minus nx1 minus mx2. So this term going that side and nx only taking on the left side. Now both are minus x I am taking common, so in the bracket m plus n, and here also I am taking minus outside, so I get here m x2 plus n x1 like this, you see, by taking minus sign common. Now both the side negative sign, so negative we remove. So x is equal to mx2 plus n x1 upon m plus n. So this is called section formula, or you can say the division point of x coordinate. So this is one formula for you students which I have derived here. which is x is equal to m x2 plus n x1 upon m plus n. Now what are x1 and x2 here? x2 is the y coordinate, x1 is the x coordinate, and m and n are the ratios here. So let us take one example for explanation and how we apply this formula. So suppose let some point be given to you. Point P is A is 3, 5 and point B is -2, 3, like this. And if I want to find some point P, which is the division point, P is division point of this line segment AB, whose coordinates are written. So suppose the ratio is given 2:3. This is the ratio given. Then how we apply this formula and get our point P value? Point P means let the coordinates be xy. Okay, so first of all I find only x coordinate of it. Using the formula here, m 2:3 means m ratio n. This is x1 y1, this is x2 y2. So first of all I will explain you how I am finding x coordinate. For that the formula is m x2 plus n x1 upon m plus n is equal to, m is 2 here, so I am placing 2. x2 is -2, so placing -2. And 3 and x1 also 3. In division m plus n, that is 2 plus 3. So here 2 plus 3. So I get here -4 plus 3 3s are 9 upon 3 plus 2 5. So that will be 5/5. It means answer is 1. So here I get x coordinate as answer 1. Means I found my x coordinate of the division point P here. Similarly students, I derive the y coordinate also. So for that you have to check the formula. Next formula for y coordinate of the division point. So now here you can see I have drawn the point A, point B on the y-axis, and there is a point section or division point, we can say point P. So point A's coordinates are x1, y1. Point B's coordinates are x2, y2. And let point P's coordinates are xy. So now what is the distance from origin of point A here? So for point A the distance will be x1. For point P it will be x. Sorry, here we are taking y distance. It means y1. This will be y. And the third, this one is y2 here. So students, you can see according to how we have solved x coordinate, we are finding now y coordinate. For that I have taken 2 points on y-axis. They are point A and B only, and the division point is P, whose coordinates are xy. So I want to find now y value here. So for that I have taken the distance, that is y distance we have to take. For that from the origin point A distance is y1, then from the origin point P distance is y, and from the origin point B distance is y2. Now let some ratio here, AP ratio PB. Same we have taken in our first formula, m ratio n. And so AP distance, how much is AP distance? You can see here y minus y1. So it will be AP. So y minus y1, I am showing you here this much distance I am telling you, from up to here to here, this much distance. This is AP, you can see AP. And that is whole y minus y1. So that way I have written here AP is y minus y1. Then the second PB ratio is equal to that distance PB. Here you see this much is the PB distance, and for that we'll take whole y2 minus y, that is PB distance, this to this. So here I write PB is y2 minus y, this much distance. So about y2 minus y. This is our PB distance. Now we take according to our formula AP upon PB is equal to m upon n. This is the ratio we have taken, and AP is y minus y1 and BP is y2 minus y. So accordingly I'll take cross multiplication. So I get here my2 minus my is equal to ny minus ny1. Now I take all the m values together and all the y values together. Means I can take this m here or all of them here. Anyway, so here I am writing m y plus ny, means I am taking this minus on this side, so it become positive. Similarly, I take in the this minus ny1 this side. So here my2 plus ny1 this way. Next is m common from this, m plus n, y common is equal to my2 plus ny1. So the formula I found here for y is equal to, you can see, my2 plus ny1 upon m plus n. So this is the y coordinate we found here as our section formula y coordinate. So both the formulas are same only, students. You have to see that only the coordinates are different. When x it is, then x1 x2, and when y it is, that is y1 y2, nothing else. So don't worry, it is very simple to remember. So you have learned here today section formula. This is nothing but section formula for the y coordinate. Y is equal to my2 plus ny1 upon m plus n, and x is equal to mx2 plus nx1 upon m plus n. Now students, here I gave you one example for the 2 points A and B. So here we have found x coordinate, but if you want to find y coordinate also, so we have to use this formula which I have written here. You can see this formula, which this we have to use to get our y coordinates. For that I am writing here y is equal to, so the same formula I am using. So formula I will not write again. You see here, so formula also you have to see y1 and y2 coordinates are 5 and 3 here, and the ratio is same, m and is 2:3. So I'll put here now m is 2, so 2 into y2 is 3 plus n is 3 and y1 is 5 upon 2 plus 3. This way after substitution we can find out 3 2s are 6 plus 5 3s are 15 upon 5. So 15 plus 6 is 21 upon 5. So this is our final answer, 21 by 5. Okay, so we get both our coordinates here, x coordinate and y coordinate. X is 1 and this is 21 by 5, students. So this way you can find out in given ratio how it is section or it is dividing our line segment. So we can find any value of a division point, or you can say section point. Any way you can say, this is the section formula we are finding. Now students, I have written here division or section formula, x coordinate and y coordinate. Now in some textbooks, instead of m and n ratios, they have given m1 m2 ratio. So no problem students, you can put m1 m2 or m and it is same. Now let here m ratio n be 1:1 or 1:1. Then we can find another formula here. I am substituting m ratio n as 1. So here instead of m 1 and instead of n also 1. आप देख सकते हैं कि m और n की जगह मैंने 1 सब्स्टिट्यूट किया है. So what do I get here? This will be x2 plus x1 upon 2. 1 plus 1 is 2 here. And similarly, here y is equal to m into y2, m means 1 and n also 1 upon 1 plus 1. So I get y2 plus y1 by 2. These are the coordinates I found here, x1 plus x2 by 2 and y1 plus y2 by 2. And these are nothing but midpoint formula. So this is our midpoint formula I am writing here. For that, this is x1 plus x2 by 2 and y1 plus y2 by 2. This is our midpoint formula, students, which I have written here. So how do I found it? By keeping my ratio 1:1. So this way I found another formula, that is midpoint formula, to get midpoint value. Now whenever you are given 2 points and its coordinates, you can substitute the values here to get your midpoint here. So today we have studied here two main formulas of this chapter. One is division formula, or you can say section formula, that is here. These two are the coordinates, and the second one is midpoint formula. This is the midpoint formula. Now we are going to learn the third formula, that is centroid of a triangle. So first of all, let us study what is a centroid of a triangle. So students, centroid means in a triangle if the point of intersection of medians. So here is the triangle ABC, you can see, in which I have drawn three medians, AD, BE and CF are three medians of triangle ABC and the intersecting point of it. So this is the intersecting point of these three medians, which I denote as G. So that point is known as centroid of a triangle. Now what is the median of a triangle? That is already explained in standard 9, but I am again repeating here that median means from the vertex a line segment which intersect or divides our the other side, that is the opposite side of the vertex. Suppose here B, so the line segment which divides AC, it means it makes two equal parts. Similarly, from point C, CF, so CF will divide AB in two equal parts. Then that line segment AD is said to be median of this triangle. Also, it is very known that this centroid is always dividing this triangle, or the median is intersecting at 2:1. That is the ratio of division here. Always you have to remember that centroid will always divide the triangle in 2:1. From the figure only you can see that AG part is bigger and GD is smaller. Similarly, GC and FG and BG and GE, they all are having 2:1 in intersection. So this is very important thing you have to remember. Then let A coordinates are x1 y1, B coordinates are x2 y2 and C coordinates are x3 y3. So students, using our section formula, I'll explain you how we derive a centroid of a triangle formula. So now for that, first of all, this D, this is the point I tell you here, this is x2 y2 and this is x3 y3. So what I told, that AD will divide BC. Division point is midpoint always. So D is the midpoint of BC. And midpoint formula is very simple. I explained you the sum of the x coordinates divided by 2 and sum of the y coordinates divided by 2. So this is our D. D means that division point or the midpoint here of BC. Now I'll tell you that here G has the coordinates x and y. So today we are going to derive x and y values. So x value here I tell you how to derive. So for that we will use our section formula. and 2:1 is the ratio of division given, and A is x1 y1 already we know. So now this is the line segment AD and G is the point of intersection here, and it is dividing in 2:1, and these are the 2 points in between this G is lie. So now I use my section formula. It is M. The M is 2 here, multiply x2. x2 means this D1. So that is x2 plus x3 by 2 plus n. N means 1 into x1. That is x1 already upon m plus n. 2 plus 1. So here you can see 2 get cancelled, and what I left with, it is x2 plus x3 plus 1 into x1 is x1 upon 2 plus 1, 3. So this is the x coordinate I found, in which x1 plus x2 plus x3 divide by 3. And same way I can show you y also. So for y, you can see here in the figure that again 2:1 and y2 plus y3 by 2 one coordinate and y1 is the other coordinate. So here I explain you that m ratio, that m to y2 plus y3 by 2 plus 1 into y1 upon 2 plus 1. This 2 get cancelled. y2 plus y3 plus y1 upon 3. So this is our y coordinate for what we are learning, centroid of a triangle coordinates. So x coordinate and y coordinate we have already derived here. You have to remember this, students, whenever centroid question comes, that in a triangle you have to find the coordinates of centroid. So you have to use this formula, x and y coordinates, that is x1 plus x2 plus x3 by 3, and that is y1 plus y2 plus y3 by 3.